Hi, this is Scott Borthman with the second of a two-part video series on support for 3D printing in vZome. In part one of the series, we looked at the new tools available in Build 34, which include Validate Paneled Surface and Panel Normals. We also looked at how to export the STL file and how to upload to Shapeways. In this video, we're going to be a little bit more practical and assume that you want to model new or different vZome struts, as I've shown here. To do this, we're going to use something new in the latest build, which is these 3D printing starters. You won't see this menu unless you have the latest build, at least build 35 of vZome 6.0 or later. The starters come as red tip struts, yellow tip struts, or blue tip struts. There are only three kinds of holes in the vZome ball, so if you're making struts, these are the only choices to connect to the ball. Let's use yellow tip struts. The starter model has a good bit of material already defined for you. In particular, we have 6 triangular yellow tips and the sprue connecting them, and the same thing for the other end of the strut. Your task will be to position the far end of the strut in the right place for the strut you want to model, and then connect the two pieces up with panels. The model also includes some built-in tools for your convenience. We have a shrink tool and a matching enlarge tool. We have the next strut offset, and we have the opposite tip rotation. You'll notice that the tips we've designed are much too large to fit into vZome balls of this size. The obvious problem when modeling these things is you need to be able to select the vertices of panels and so forth. So you really want to work at a large scale. So that scale has already been defined for you in these two tools. And we can demonstrate that by selecting this end model and shrinking it, and then you'll see it quite obviously becomes the right size for the real vZome ball. You'll also see that the model comes with some sample struts, some of the struts you might want to model using these triangular tips. So these are all the vZome modeled struts that use the triangular hole at the moment. You notice I've made them fairly short struts. This is so that we don't get too far away from the origin and make navigating around our model difficult. So I encourage you, whichever strut you're going to model, make a very short version of it. The first step is to select the sample strut that you want to model. So let's select the orange strut, and we're going to select neighbors so that we have the two balls attached, and we're going to enlarge that strut. Now, of course, the enlargement simply lengthens that strut, and now we have a ball at the end position which is appropriate for the size at which we're designing. So we'll deselect that. The first thing we're going to do is to move our end tips into the right position, and that's very simple. We're going to simply translate from this ball center to this ball center, and it's just a matter of modeling the panels to join them. The easy way to do this is just to select this ball and apply icosahedral symmetry. To get an even better idea, let's make one of the rectangular panels and then apply symmetry again. So that's the size of the vZome ball at the scale we're working at. Generally, the aesthetic I apply when I'm modeling a strut is to make sure that the main body of the strut, the panels that'll lie along its length, lie parallel to the center line of the strut, the line joining the two balls at the ends. That makes the strut look like it goes in the right direction. But of course, it doesn't go into the ball perfectly at that point, so we have to make some adapting area between the main prism or anti-prism body of the strut and the triangular hole we're going to go into. So to do that, we're going to use an orange strut, and let's start from the origin again, and that looks like a reasonably good length. That's a pretty short adapter, or frustum as I call it, but that's okay. I'm going to go ahead and look at this. I simply can click on that panel, any of those yellow panels, and say set working plane, and click on use working plane and all, and now I can build struts that only lie in that plane. Any of these struts would be useful to form a polygon that will extrude as a prism for the main body of the strut. Let's just use purple because I know that's the right direction here. Fairly short purple, so that's going to be at right angles to blue here. I don't actually want anything that big as blue. If you want to get the half length correct, you can select that length of blue and then cut it in half. And now you have a half length blue. So let's make a diamond cross section for our strut. Now we can start to model the frustum. So we're going to make panels. As usual, we need to make them in the counterclockwise order as facing outward from the interior. It's pretty straightforward. Okay, so there's our frustum. I'm going to select all of the panels. I'm going to group them, and then I'm going to apply the opposite tip rotation. I'm going to simply cut. I will paste at the other end, and I'm going to immediately group those so I can reselect them easily. So now we have our two frustums. To do that, I need these balls at the end. So the easy way to do that is to select these four vertices. Again, do my rotation, cut, and paste trick. And there we have the balls. Okay, so now I can build these panels. Again, being careful to select in counterclockwise order. I'm using Command P to make the panels. Okay, so I have all four of my panels. Oops. Let's select those four and group them as well. And now we're nearly done. So now we can select our three groupings and apply our next strut offset tool. I like to group these as I go, so I'm hitting Command G. I like to see what I'm doing, so I'm going to back out a little bit. Okay, I need to get rid of the ball panels here, so let's just delete those. I'm not going to worry about balls and struts here. The only thing that will remain after I do my validation will be the panels. So let's check that we have a good watertight surface, and it looks like we do. We don't have any holes, the panels did not disappear, and we don't have any extra balls or struts showing us any defects. So it looks like our mesh is watertight. So there's one last step. If I go ahead and click on ball at origin, you'll be reminded that these struts are much, much too big to go into any Zome ball. So we need to get everything down to the right size. So I'm going to select all and use my shrink tool. And I'll look at origin too. Group what we have left. We'll bring back the ball at origin. We'll go ahead and select orange struts, and we'll build a small orange strut and make sure that it lines up with our new model, and sure enough it does. So at this point, if you like, you can do one last check and validate the paneled surface. Should be no problem. If it's fine, you're ready to export to STL and upload to Shapeways or use it in your own 3D printer. That's it for this video. Thank you for watching.